Here I want to explore the sine parent function, which we'll call y equals sine of x. And I call it a parent function, but it's basically the sine function with no transformations, no shifts or stretches or any of that. Okay, and the important thing to realize here is that the input to this function, we're going to consider the input as an angle. Sorry for my handwriting. In radians, in rads. That's because we'd like for the x-axis on our graph to not have a unit, so I don't want to use degrees. Okay, so here's the idea. We're going to look at the sine function in the plane to generate, so we're going to look at angles over here to generate an xy table maybe, and to understand the graph of y equals the sine of x over here. So this is x, this is the vertical axis is y. And so we might start with an x value of 0. So I'm looking for the sine, y is the sine of x, I'm looking for the sine of 0. So I'm looking over here at the angle 0, and so I'm looking at a terminal side that sits here on the positive x-axis, and sine is the vertical side divided by the hypotenuse of my reference triangle. Well, the vertical side is 0 here. There is no vertical component. So I get 0 over a hypotenuse of 1, which of course equals 0. So I get the ordered pair 0, 0 on my sine graph over here. And then maybe I skip all the way up to the angle pi over 2. Okay, so we'll do that. If I look at x equaling pi over 2, then I need to know the sine of pi over 2, which here the vertical side is 1, and if I'm working with a hypotenuse of 1, that ratio equals 1. Okay, so that means over here, when my x value, my angle is pi over 2, my y value is 1. And notice here that my x-axis is going to be in radian measures, in other words, in terms of pi for this basic function, while my y-axis is going to be measured in terms of numbers, like just a ratio of numbers, not going to be involved in pi at all. That can happen. You can use a different scale on your x-axis from your y-axis. Okay, so I know that as I rotate here, the sine function starts at 0, vertical component, and up here it hits a vertical component of 1. So what happens in between? So what you could do is, if you start drawing reference triangles here, like at this point, this angle, whatever it may be, the vertical side here is short while the hypotenuse is 1, and as you move up here and get closer to pi over 2 as your angle, your vertical side gets longer with the same hypotenuse of 1. So as you rotate from 0 to pi over 2, the vertical side goes from 0 to 1, so it's going to grow. And in fact, hopefully you can tell that initially your vertical side is going to grow really fast as you rotate, and as you get to the top here it flattens out and grows slower. So that's the behavior we'll see on the graph. As I rotate from 0 to pi over 2 on my x-axis, it's going to increase rapidly, and then as it gets close to 1 up here, it's going to sort of flatten out. It's going to slow down. Okay, so that's the sine graph from 0 to pi over 2. Now let's go and rotate to an angle of pi. So I'm looking at this terminal side. Well, at pi, the vertical side is 0 again, and the hypotenuse is 1. So we get a ratio of 0. So at pi, I'm back down here at 0. And you can see again, as you rotate, it does the exact reverse of what it did as it rotated from 0 to pi over 2. It starts with a big vertical side, and then it grows or shrinks slowly and starts to speed up as it gets over here closer to pi. So it starts going down slowly, and then it speeds up as it gets over here to pi. So it looks something like that. Alright, let's rotate down to 3 pi over 2. At 3 pi over 2, the vertical side is -1 with a hypotenuse of +1. You always use a +1 for your hypotenuse, which gives you a ratio of -1. So at 3 pi over 2, the y value is -1 down here. And you can imagine it's the same pattern, right? It's going to grow, your vertical side for sine is going to grow fast initially, grow fast, and then it's going to get slower and slower. So it's going to grow in the negative direction. You get negative values here for the sine function. And they decrease quickly, but as it gets closer to 3 pi over 2, it flattens out. And hopefully you can see as you rotate from 3 pi over 2 back to now 2 pi, this angle could be thought of as 2 pi also, it's going to end up back at 0 again with the same sort of behavior. Okay, so it does this kind of thing. And I bet you can tell, if you kept rotating, you could think about this as being 5 pi over 2. At 5 pi over 2, it's going to start repeating. It behaves the same way. So you're going to get, and I'm going to kind of draw this in as a dashed line, the graph is going to repeat this behavior forever. And in fact, if you go in the negative rotation, you're going to get the same thing. It's going to continue the same pattern forever. You get this infinite wave. Okay? So several things here. This type of graph that exhibits a behavior and repeats is called periodic. Repetitive behavior. Okay? And what we call this is you go through one cycle of the graph. So if you look at this, you get through one revolution of the plane and you get one cycle of the sine function. That is called the period. So the period is the length of one complete cycle, which in this case goes from 0 to 2 pi. So the period in this case is the length of 2 pi. Okay? That's how long one cycle takes, 2 pi, from 0 to 2 pi. Then we have what's called the amplitude. Or let's tackle it this way instead. I apologize. Let me kind of move our XY table out of the way for a moment so we can talk about this. Let's erase this arrow. We'll have more room. Okay. So this graph repeats, but let's talk about what's called the average value now. You can see this graph oscillates. It goes up to 1, down to -1, back up to 1, down to -1. It oscillates between -1 and 1, okay? And the number that's in the middle of this oscillation is called the average value. So here, the average value equals 0. That can change if your graph shifts up or down. So your average value can vary. The last definition I want to give is what we call amplitude. Amplitude is how far does the graph, how far does the graph deviate from the average value. So in this graph, the amplitude, again, is how far the graph deviates from the average value of 0 in this case. Well, it goes 1 above and 1 below. So the amplitude here is 1. So we have amplitude, period, and average value. And we have our basic sine graph. And so what you kind of want to take away from the sine graph starts at 0, goes up to 1, back to 0, down to -1, back to 0, and repeats. Okay? So that's the behavior of the basic sine parent function.